Welcome everyone, and thank you for attending this webinar. The goal of today's session is to introduce the required updates to your file protection curriculums to include the standardized file clearance calculations. My name is Kim Lewis, and I'll be your facilitator today. I am a certification training specialist with WorkplaceNL, and I'm also a former file protection trainer. In accordance with our file protection certification training standard, WorkplaceNL is continually monitoring the quality, integrity, and delivery of training to ensure it is effective, current, and meets the needs of workers. Through trainer assessments and audits, WorkplaceNL found that students often have difficulty understanding, and some trainers have difficulty teaching free file distance and minimum clearance calculations. Varying methods of calculation, calculations requiring different mathematical operations, a lack of emphasis on the importance of free file distance separate from minimum clearance required, and an overall intimidation of math were found to contribute to these difficulties. To address these concerns, following consultation with the Occupational Health and Safety Division of Digital Government and Service NL and the File Protection Technical Advisory Committee, WorkplaceNL has standardized free file distance and minimum clearance calculations to ensure consistency amongst training providers and for ease of worker understanding and use when completing file prevention plans. I'd just like to take a minute to elaborate a little on the previous reference to free file distance and the minimum clearance required calculations being combined. Under the current standard, free file distance, total file distance, and minimum clearance required are separate subtopics, but they are often taught together. Part of the reason for this is how it is laid out on the curriculum review form. And this blurs the line on the topics, and the teaching methods need to be revised. Students must be taught to treat free file distance and minimum clearance required as separate entities, as they are calculated for different reasons and have different consequences. Total file distance, as requested in the curriculum, is important but insignificant without minimum clearance required, and it also adds an unnecessary step. The goal is to simplify the calculation for effective training that is easily understood and remembered. Through our quality assurance processes and interaction with students, training providers, and trainers, we have found the standardized calculation to be the most effective method to emphasize the free file distance and easily understand how to ensure you do not contact the nearest safe surface if a file occurs. Some training providers currently use this method and some do not, but going forward, this will be the required method for all approved curriculums. Following participation in this session, training providers are required to add the free file distance and minimum clearance required calculation slides to their curriculum, replacing the old training. Training providers can use the slides directly and apply branding if desired. You can also create your own slides from a visual perspective. However, the provided content must be discussed and the calculation performed as outlined. In situations where slides are recreated, they must be submitted to WorkplaceNL for approval. It is the responsibility of the training provider to ensure there are examples and exercises for students to complete to ensure understanding. WorkplaceNL will not be providing these. The free file distance and minimum clearance required calculation slides will be provided to training providers via an email link to Dropbox. Training providers are required to notify WorkplaceNL when the curriculum changes have been completed. This must be done on or before September 1st, 2022. Confirmation can be sent to ohs.training@workplacenl.ca. Failure to provide confirmation or a quality assurance audit revealing that curriculum has not been updated may result in a suspension of training provider approval. So the following slides will be the standardized slides provided to training providers to update the file clearance calculation in their curriculum. Calculating free file distance and minimum clearance required are two very important components of the pre-job hazard assessment and file protection plan when performing work at height. These distances must be calculated before work starts. Failure to consider these distances may result in the user exceeding the limitations of the equipment or striking the ground or other safe surface prior to full deployment of the file arrest system. Manufacturer specifications outline the maximum allowable free file distance. If conditions exist that a worker will fall from a work area and contact a safe surface below, the worker shall do whatever is necessary to prevent a free fall of greater than 1.22 meters. That could be relocating the anchorage point to reduce the free fall distance, changing the scope of work, or changing the equipment necessary to continue with the task. So just a short disclaimer before we begin. The following examples are for general calculations and are completed using the upper limits of the scale for safety. Where an employer needs to calculate the exact minimum clearance required as part of their risk assessment process, they may use manufacturer's instructions and a subject matter expert to determine the calculation. This level of calculation must be completed by a trained professional who understands the forces associated, the equipment, and the limitations of that equipment. The following information is for a standard lanyard. The calculations for use with self-retracting lifelines, rope or rail grabs, lifelines, etc. will vary and carry their own risks. Always consult and follow the manufacturer's instructions when using any equipment to understand the risks and hazards of that equipment. Do not assume what is presented in the following slides will be acceptable for all equipment. The Canadian Standards Association defines free fall distance as the vertical distance traveled by a worker from the start of a fall to the initiation of an arrest force. Essentially, this is the distance from the point where you fall until the energy absorber begins to slow your fall. Understanding free fall distance and being able to calculate the free fall distance is critical to keeping workers safe. When planning to work at height using a fall arrest system, the first calculation that must be done is free fall distance. This calculation must be done separately or independently from the minimum clearance required calculation. When combined, it is easy for a worker to miss or skip over an exceedance in the free fall distance. If maximum free fall distance is exceeded, work must not proceed as the equipment is being used outside of its specifications and limitations. In such situations, work must stop and be re-evaluated and must not proceed until the manufacturer's maximum free fall distance has not been surpassed. This is a critical step in the fall protection planning process. As per CSA ZAD 259.11-17 energy absorbers and lanyards, maximum free fall distances are set by the manufacturer, therefore they may differ. They may differ from manufacturer to manufacturer, and they may also differ by the type of equipment being used. This information can be found on the equipment label. In this case, both are 3M lanyards with different maximum free fall distances. These lanyards would be suitable for different tasks. As part of the pre-use inspection and pre-job hazard assessment process, workers must know and understand the limitations of their equipment. We will now go over how to calculate the free fall distance. When calculating free fall distance, the location of the anchor point is important, whether above the D-ring, level with the D-ring, or below the D-ring. When anchored above the D-ring, the free fall distance will be the length of the lanyard minus the distance from the D-ring to the anchor point. So the higher the anchor point above the D-ring, the shorter the free fall distance. If anchored level with the D-ring or at shoulder height, the free fall distance will be the length of the lanyard. A worker will fall the length of the lanyard before fall arrest will be initiated. Where the anchor point is below the D-ring, the free fall distance will be the length of the lanyard plus the distance from the D-ring to the anchor point. So the lower the anchor point below the D-ring, the longer the free fall distance. So in summary, if the anchor point is above the D-ring, free fall distance is the lanyard length minus the difference from the D-ring to the anchor point. If the anchor point is level with the D-ring, the free fall distance is the length of the lanyard. And if the anchor point is below the D-ring, free fall distance is the length of the lanyard plus the distance from the D-ring to the anchor point. There are 3 calculation examples on this slide showing free fall distance when anchored above, level with, and below the D-ring. On the left, the worker is anchored 2 feet above the D-ring. We know that anchoring above the D-ring shortens the free fall distance. Therefore, free fall distance is the length of the lanyard, L, minus the distance from the D-ring to the anchor point, D. In this case, free fall distance is 6 feet minus 2 feet, which gives a 4-foot free fall distance. In the center diagram, the worker is anchored level with the D-ring, or at shoulder height. Therefore, the worker will fall the length of the lanyard before fall arrest is initiated. In this case, 6 feet. And on the right, the worker is anchored 2 feet below the D-ring. We know that anchoring below the D-ring lengthens the free fall distance. Therefore, free fall distance is the length of the lanyard, again L, plus the distance from the D-ring to the anchor point, which is D. In this case, free fall distance is 6 feet plus 2 feet, which gives an 8-foot free fall distance. Where the manufacturer's stated free fall distance is exceeded, the work cannot proceed and alternatives must be considered. For example, relocating the anchor point, using a shorter lanyard or a self-retracting lanyard, or changing the scope of the work, etc. Where the free fall distance has not exceeded manufacturer specifications, the next calculation to be performed as part of the pre-job planning process is minimum clearance required. Minimum clearance required refers to the minimum distance required to safely arrest a person's fall. Calculating the minimum clearance required prevents fallen workers from coming into contact with obstructions below, it reduces the risk of serious injury, and it may even prevent a fatal accident. It is also a critical factor in the selection of proper fall protection equipment. The minimum clearance required calculation focuses on the distance between the anchor point and the nearest safe surface or obstruction. A worker should be able to look at the anchor point, visualize the components of the system connected to that anchor point, and how they would elongate or lengthen in a fall arrest. Thinking about that anchor point and the components of the fall arrest system, minimum clearance required, or MCR, is calculated by adding the following variables. So first is the length of the lanyard, or L, followed by the energy absorber elongation, or E. These are connected to the dorsal D-ring, which may cause D-ring slide or harness stretch, which is D. Then comes the height of the worker, H. And lastly, the safety factor, S. So when it comes to the distance to include for D-ring slide and a safety factor, these values may be found in the manufacturer specifications, generally allowing for 1 foot for a D-ring slide and 2 feet for a safety factor would meet or exceed these specifications. When calculating minimum clearance required, we use the maximum energy absorber elongation as specified by the manufacturer. While it is possible that the energy absorber may not deploy to its maximum elongation, without additional knowledge and training and experience beyond that which we cover in the fall protection training, it will be difficult to accurately guess or determine the exact elongation following a fall arrest. So for the purpose of this training, it is safer to use the manufacturer's maximum energy absorber elongation in the calculation. Using a value other than that would be at the discretion of the employer. If we take a look at this equipment label again, you'll also notice the maximum energy absorber deployment distance may vary. This is unlike the previous version of CSAZ 259.11, where a specific energy absorber elongation was referenced. This is no longer the case. Users must check the maximum energy absorber extension before use. So this can vary substantially. So before completing your minimum clearance calculation, please ensure that you have incorporated the correct energy absorber elongation. As you can see in the examples above, one is 42 inches or 3.5 feet, and the other is 60 inches or 5 feet. So as noted, these distances will vary, and those illustrated here are not the only lengths of deployment, so they can be longer and they can be shorter. So again, you must know and understand the limitations of your equipment as part of your pre-use inspection and pre-job hazard assessment processes. So in this example, a 6-foot tall worker is using a 6-foot lanyard with an energy absorber that can elongate to 6 feet. Using 1 foot for a D-ring slide and a 2-foot safety factor, the worker would need approximately 21 feet of minimum clearance below the anchor point. Regardless of where the anchor point is located, the worker requires 21 feet of clearance below that anchor point to safely arrest their fall and prevent them from coming into contact with obstructions below. Please recognize that the examples that we give today are for illustration purposes only. The factors stated here can and often will change based on the length of the lanyard, the maximum energy absorber elongation, the height of the worker, the safety factor, and the D-ring slide. So it is critical to follow manufacturer's instructions to make adjustments as necessary. Once a worker understands this calculation, it's just a matter of adjusting the variables to suit the situation. For example, if a 5-foot tall worker is using a 4-foot lanyard with an energy absorber elongation of 4 feet, and we keep the D-ring slide and safety factor the same, the worker would need approximately 16 feet of minimum clearance below the anchor point. So regardless of where the anchor is located, the worker requires 16 feet of clearance below that anchor point to safely arrest their fall and prevent them from coming into contact with obstructions below. A worker should be able to examine the equipment they have, look at where the anchor point is located, and quickly and easily determine whether they have the minimum clearance required. If the minimum clearance required is not present, the worker must not proceed and alternatives must be considered. To summarize what we've discussed, we have developed a flow chart to help workers in their decision making of when to proceed with the task requiring fall protection and when to stop and reassess the situation. The first step would be to determine the free fall distance, or the FFD. Free fall distance is the vertical distance traveled by a worker from the start of a fall to the initiation of an arrest force. The maximum free fall distance will be indicated by the manufacturer. It is critical that you understand the maximum free fall distance. Remember, free fall distance must be calculated first, independent of the minimum clearance required calculation. If maximum free fall distance is exceeded, do not proceed. Work must not proceed, and before determining the minimum clearance required, you must ensure the maximum free fall distance is acceptable and within manufacturer's specifications. If maximum free fall distance is not exceeded, proceed with the minimum clearance required calculation. Minimum clearance required refers to the minimum distance required to safely arrest a person's fall. Calculating the minimum clearance required prevents fallen workers from coming into contact with obstructions below, reduces the risk of serious injury, and may prevent fatal accidents. So then the question becomes, do you have enough minimum clearance required to proceed? If yes, proceed to perform the work. If no, do not proceed with work and make adjustments to ensure the work can be completed safely. So the next steps for training providers are as follows. Access slides via the email link to Dropbox. Update curriculum by using the slides directly and applying branding if desired. Or you can also create your own slides from a visual perspective. However, the provided content must be discussed and the calculation performed as outlined. In situations where slides are recreated, they must be submitted to WorkplaceNL for approval. It is also important to remember that WorkplaceNL is not providing the practicals or examples. It will be the training provider's responsibility to update the course to include practicals as required to ensure students understand how to perform the calculations. Then provide confirmation to WorkplaceNL by September 1st, 2022 at ohs.training@workplacenl.ca. If you have any questions, you can reach me at kim.lewis@workplacenl.ca or by telephone at 709-778-4806. Thank you for attending today's webinar and for working to ensure consistency amongst training providers and for ease of worker understanding and use when completing fall prevention plans.